Hello everyone! So now that we're done with how the latent image is formed and it is turned into a manifest image by the help of our processing chemicals, let's now proceed to the radiographic image quality. Okay, so on this lecture, we will see the factors that affect the image quality. And as a radiographer, we should know those factors in order to produce a high-quality radiograph. When we say a high-quality radiograph, it is a radiograph that faithfully reproduces structures and tissues. Why do we need to produce a high-quality radiograph? So in order to produce or to help our radiologist for an accurate diagnosis. First, let's define what is radiographic image quality. So it refers to the fidelity with which the anatomical structure that is being examined is rendered on the radiograph. It is also defined as the exactness of representation of the patient's anatomy on a radiographic image. So in short, when we see radiographic image quality, the part under examination or the part being examined should show or should be shown on the radiograph. So that's the reason why we are here radiographers. So we are dealing with different imaging modalities. So dun muna tayo sa simple, which is the X-ray. We are dealing with X-ray machines or X-ray examinations to let our doctors or to help our doctors diagnose a disease. Because an X-ray can help to see the abnormality inside the patient. Alright? But the radiographic image or the quality of a radiographic image is not easy to define and it cannot be measured precisely. So there are a number of factors that may affect the image quality, which is yun yung malalaman natin in this lecture. But again, these factors is not precisely, but it is universally accepted as a measure to judge our radiographic image quality. So there are important characteristics of radiographic image quality, but I have 4 here. First, we have the spatial resolution or the spatial resolution. Next is the contrast resolution. Third is the radiographic noise. And last is the artifact. Okay, so as you can see, we have spatial resolution and contrast resolution here, which is in or under the resolution. When we say resolution, it is the ability to image 2 separate objects and visually distinguish one from the other. So, kumbaga, pag sinabi nating resolution, ito yung pagkakaiba ng shades of gray or pagkakaiba ng details or ng sharpness sa image. First, let's define what is spatial resolution. So, it is the ability to image small objects that have high subject contrast. So, si spatial resolution yung bahala dun sa mga maliliit na parts ng katawan ng tao. Si spatial resolution yung magsasabi kung anong part to. Usually, kapag spatial resolution, these are the calcifications or yung mga stones inside the patient's body or yung mga fragments ng fracture. Yun yung magdedetermine ng spatial resolution. Okay, so next is contrast resolution. Contrast resolution is the ability to distinguish anatomical structures of similar subject contrast. So, kay contrast resolution, dito natin makikita yung difference with the shades of gray. Kasi di ba kapag gray, ang hirap niyang ma-determine. Okay, so an example for this is the difference between the liver and spleen on an abdominal radiograph. Liver and spleen is not radiopaque material when we are viewing an abdomen radiograph. These are radiolucent. But still, when we have a proper contrast resolution on our radiograph, we can differentiate which is the liver, which is the spleen, as well as the kidneys. Next is radiographic noise. So radiographic noise, it is the random fluctuation in which the optical density of the image. Okay? It is a random fluctuation in the optical density of the image. Ito yung tinatawag natin na salt and pepper appearance sa ating radiograph, yung radiographic noise. Last is the artifact. It is the unintended optical density on a radiograph or another film type image receptor. Si artifact, those are the unwanted na mga image na napapunta sa ating radiograph. Again, these are the 4 important characteristics of a radiographic image quality. We have spatial resolution, contrast resolution, radiographic noise, and then artifact. Okay. So, spatial resolution. Spatial resolution is excellent in terms of a screen film radiography. Okay? So, spatial resolution can be measured by the help of the line pair test pattern. Okay? So, when we say line pair test pattern, this is consisting of lead lines separated by interspaces of equal size. Okay? So, the spatial resolution is expressed by the number of line pairs per millimeter that are imaged. So, using the line pair test pattern, we can radiograph it or we can expose it para makita kung gaano ka-sharp ang ating image. Si line pair test pattern, it is consisting of lead lines with equal interspaces. Kapag mataas ang bilang ng line pairs, it means that the smaller object can be imaged. Okay? Again, kapag mas madaming line pairs ang lumabas sa radiograph after exposing a line pair test pattern, it means that the smaller object can be imaged. Therefore, the spatial resolution is high. Okay? So, let me show you the different values of the spatial resolution. Okay. So, for very fast screens, we have a 7 line pairs per millimeter. Very fast screens ito ha. For fine detail screens, we have 15 line pairs per millimeter. Compared to a direct exposure film. When we say direct exposure film, we are not using any intensifying screens. Dito, sa ganitong klase ng plaka or ng film, mataas ang spatial resolution. Kung naaalala ninyo sa nauna pa nating mga topics. Okay? So, direct exposure film has a 50 line pairs per millimeter. Compared to our unaided eye or naked eye, the spatial resolution for our unaided eye is 10 line pairs per millimeter. Again, the spatial resolution is high when we have more line pairs in the image. Okay? Kapag mataas yung value ng line pair na nakita natin, it means that the smaller object can be imaged. Therefore, there is an increased spatial resolution. So, compare natin si very fast screen and si fine detail screen. Fine detail screen has a higher spatial resolution compared to a very fast screens. Okay? So, there are terms or less precise terms like detail and recorded detail. So, these less precise terms are sometimes used instead of spatial and contrast resolution. So, when we see recorded detail, it refers to the degree of sharpness of structural lines on a radiograph. Okay? But when we say sharpness, ang unang papasok sa utak natin is yung mga small image can be seen on the radiograph, which is yung mas responsible doon is our spatial resolution. Kapag naman ang hinahanap natin is differences in shades of gray, we have contrast resolution for that. So as you can see on this image, okay, so as you can see on this image, the line or the outer line of the bones are well defined. Okay, even the hyoid bone is seen. It means that the spatial resolution for this image is high. Okay, for contrast resolution, let's see this image. This is an abdominal image in anterior-posterior projection or in AP projection. Ang unang makikita nyo dito is the vertebral spine, specifically the lumbosacral spine. Also the pelvis of the patient makikita. But can you determine which is which of the structures in the radiograph is the liver and the kidneys? Okay, so let me help you. This outline here is the kidney. Alright, this is the kidney of the patient. And this outline here is the liver. So that's what I'm talking about when we say contrast resolution. We can see the outline or the borders of the structure, even though it's not radiopaque in the appearance. But when we say radiopaque, it appears white on the image. Okay, compared to bone, our kidneys are less white or less dense. Alright, so when we have a better contrast resolution, we can determine which of the following structures is the kidneys or the liver. This is the intestine. How can I say so? Because it has air. Okay, air is a type of a contrast medium, negative contrast medium, that helps to enhance the structure. Alright? So that is a contrast resolution. Now, let's proceed to the radiographic noise. Actually, when we say noise, it is a borrowed term for electrical engineer, or it is an electrical term. We have an audio noise or video noise. When we say audio noise, those are the flutters or the hum and whistle that can be heard from an audio system. Those are inherent in the design. When we say inherent, andun na siya. Hindi siya mapapalitan. Naka-program siya. Parang ganun. So for video noise, maybe some of you have already seen yung parang may snow sa ating TV. Kapag nagagalaw yung antena, nawawalan ng signal, parang nagsusnow. So those are also inherent in the system of our video. This appears when we have a very weak signal areas, yung snow. So it means when we see radiographic noise, it is also inherent on our materials, may it be from the intensifying screens or the film itself. So there are components of the radiographic noise. But before that, let's see this image. The first image, as you can see, it's like grainy. It's like sandy. And that is the noise or the radiographic noise. Let's compare it with letter B. Letter B is smoother compared to letter A. Okay, so what are the components of radiographic noise? First, we have film graininess. Okay, So when we say film graininess, it refers to the distribution in size and space of silver halide grains in the emulsion. Again, as I've told you, radiographic noise is already inherent on the film or in the material that we are using. So again, film graininess refers to the distribution in size and space of the silver halide grains in the emulsion. Next is the structure model. Structure model is different with the quantum model. Structure model is somehow similar to film graininess, but it refers to the phosphors of our radiographic intensifying screens. Okay? So it means that this phosphors also refers to its distribution and sizes, and even the spaces between them. So the film graininess and structure model are inherent with the materials, with the base, and our intensifying screens. These two contributes very little to the radiographic quality. Can a film graininess and structure model can be controlled by a radiographer? No, because as I've said, these are inherent on the materials that we are using. It's already manufactured. Next component of radiographic noise is the quantum model. Okay, so quantum model refers to the random nature by which X-rays interact with the image receptor. This component of radiographic noise can be controlled by a radiographer. Okay, so when we say kasi quantum model, it's like maybe some of you have already read this part in Busho. So quantum model is very similar to the sowing of grass seed. So pag sinabi nating sowing of grass seed, it's like kapag nagbuga tayo ng grass seed or ng seed ng halaman na maunti. And it comes to the period na bubunga siya. Di ba yung kaunting yon, kaunti lang din yung bubunga. Very few yung magre-result. It will be thin grass. Okay? So this is the quantum model. Only few X-rays can reach our image receptor. And these few X-rays, sila lang yung nag-i-interact. Therefore, there are parts na walang signal. There are parts na hindi na-reach. There are parts na walang interaction. Okay? So, if an image is produced with just a few X-rays, the quantum model will be higher than if the image is formed from a large number of X-rays. Okay? So, the use of high MAS, low KVP, and slower image receptor can reduce quantum model. Again, as I've said, quantum model can be controlled by the radiographer. We can do something to prevent quantum model. Alright? So last for the components of radiographic noise is scattered radiation. Scattered radiation is the primary source of radiographic noise. Usually, scattered radiation can be get from using a high KVP. Okay? As we all know, KVP is the energy that pushes our electrons para mag-form tayo ng X-ray. And we know that using a high KVP, there's a chance na mas mataas yung penetrability action of our X-rays. But this high KVP can produce Compton interaction. And we know that in a Compton interaction, we are producing scattered radiation. This scattered radiation is low energy X-rays. Okay? These are low energy. And once this reaches our image receptor, there could be possibility na magkaroon din ng interaction nakakaunti that will result into quantum model. Can you get that? Again, as we use a higher KVP, there is a tendency that we may produce a higher amount of scattered radiation. This scattered radiation is low energy. Once this low energy interacts with our image receptor, there is a tendency na magkaroon tayo ng kaunting X-ray na mag-i-interact sa image receptor, resulting in a very few interactions. Ito yung mag-iitsurang maninipis na damo. So in short, when we have a scattered radiation, we will produce a quantum motel. So, to prevent quantum motel, we have to use a higher MAS, lower KVP, and slower image receptors. Alright, so that is the components of a radiographic noise. Okay, so now we're done with the 4 most important characteristics of the radiographic image quality. We have the spatial resolution, the contrast resolution, the radiographic noise, and the artifacts. Now, there are 2 characteristics that are somehow interrelated with the other characteristic, which is speed. Okay, so when we say speed, it is the ability of our intensifying screens to produce light. Okay, so we have factors regarding speed, or we have factors that may affect screen speed, and those are the type or composition of the phosphor, thickness of phosphor layer, size of phosphor crystal, and reflective layer. So when we have a thick phosphor layer, a large phosphor crystal, and then nag-add pa tayo ng reflective layer sa intensifying screen, the screen speed will increase. Okay? So, ang kailangan gawin is magagamit tayo ng screens na mabagal. Pero, kung walang available na mababagal na screen, we can adjust with the technical factors. Okay, as nakalagay dito, fast image receptors have high noise and low spatial resolution and low contrast resolution. Why do we need to prevent radiographic noise? As this noise can decrease the resolution of our image. It will decrease the spatial and contrast resolution. But if our screens are high speed, meaning it contains large phosphor crystals, it contains thicker phosphor layer, it contains reflective layer, there's a tendency that the radiographic noise will be higher on every examination that you will perform. Okay? So high spatial resolution and high contrast resolution require low noise and slow image receptor. As I've said, kung hindi naman available sa mga facilities yung slow image receptor, we can adjust with the technical factors. Low noise accompanies slow image receptors with high spatial resolution and high contrast resolution. So again, remember that screen speed affects resolution. Screen speed affects the detail. Okay? A higher screen speed will decrease the recorded detail, as it will decrease the spatial resolution and the contrast resolution. Okay? So now let's proceed with the radiographic quality. So to produce a high quality images, radiographers apply knowledge of 3 major interrelated categories of radiographic quality. And those are film factors, geometric factors, and subject factors. So first, let's proceed to the film factors. When we say film factors, these are inherent in your radiographic film as well as the intensifying screens. Hindi mo mababago yan. Andyan na yan. It's already manufactured. First, let's proceed to density. So density, or the optical density, it is the degree of blackening on the radiograph. Okay? So, when we say optical density, the controlling factor of it is MAS. Okay? The controlling factor of the density is MAS. Siguro nag-iisip kayo, hindi po ba KVP ang nagko-control sa density? KVP is somehow affecting the density on the radiograph. But its main controlling factor is MAS. So, bakit po? Bakit naapektuhan niya ang density? Bakit siya yung nakaka-apekto sa density? MAS is responsible for the amount of electrons that will push through the intensifying screen, that will reach our intensifying screens. So it means if you have high MAS, it means you have a higher number of X-rays that could probably interact with the patient as well as the image receptor. There's a possibility that having a high MAS, you have a high number of X-rays that will pass through the patient, reaching out our image receptor. As this image, or as these electrons reaches the image receptor, it means mas mataas or mas madami ang magkakaroon ng interaction. Did you get that? Again, MAS is the quantity of electrons. So it means higher MAS, higher electrons, or higher number of electrons that could possibly have an interaction with our film. Kaya din siya tinatawag na having high MAS will have a higher patient dose. Kasi malaki yung amount na ibinigay natin na radiation sa patient. Okay? So that is higher MAS. So once na madami yung nailabas na electron or na X-ray using higher MAS, mas madami ang magkakaroon ng interaction. Kapag madami nagkaroon ng interaction, madami ang magkakaroon ng exposed silver halide crystal. Diba? So, higher exposure of this silver halide crystal, mas tataas yung madedevelop na black metallic silver. Okay? So, this black metallic silver is our density on the radiograph. Again, as the MAS value is increased, the radiation quantity increases. Therefore, the number of X-rays arriving at the image receptor increases. It will result in an increased optical density and decreased radiographic noise. But it will increase the patient dose. So that is our density. Next is the contrast. Okay. So when we say contrast, these are the variations of the optical density. So radiographic contrast is a product of two factors, which is the image receptor contrast and the subject contrast. When we say image receptor contrast, it deals with the materials of our image receptor, specifically the phosphors. When we say subject contrast, these are the contrast that is produced by the patient. Okay? So, pag pinagsama si image receptor contrast and the subject contrast, we will have a radiographic contrast. The primary control of radiographic contrast is KVP. Okay, tatandaan, the primary controlling factor of contrast in radiograph is the KVP. As the KVP increases, both the quantity and the quality of X-radiation are increased. Therefore, a greater number of X-rays are transmitted through the patient, so a higher portion of the primary beam reaches the image receptor. Thus, KVP also affects optical density. Among X-rays that interact with the patient, the relative number of Compton interaction increases with increasing KVP, resulting in less differential absorption and decreased subject contrast. Therefore, an increased KVP, there will be an increased spatial resolution, reaches image receptor. And then, the radiographic noise is higher. So there is a low contrast. Again, I'm sorry. May nagkamali ako. Again, increased KVP, meaning you will produce an increased scatter radiation, hindi spatial resolution. Increased KVP, you will produce a higher scatter radiation. Bakit tayo magkakaroon ng scatter radiation? Kasi magkakaroon ng Compton interaction. During the Compton interaction, we will produce a higher scatter radiation. This scatter radiation will reach our image receptor. Therefore, kapag na-reach ng scatter radiation si image receptor, it will appear as quantum motel kasi maliliit lang na energy yung lumapit sa ating image receptor. Nagigets? Maliit lang yung dumating si image receptor. Konti lang yung nagkaroon ng interaction. Mag-appear siya as radiographic noise, as sandy or grainy appearance. So, kapag may radiographic noise, alam na natin yan. Bababa ang detail, ang recorded detail. Bababa si spatial resolution and si contrast resolution. Alright? So, kapag bumaba yun, ibig sabihin, mababa yung contrast natin. Pero mag-a-add tayo ng density. Bakit pa mag-a-add ng density? Gawa ng ating scatter radiation. Alright? So, that is the contrast. Next, speed. So, speed is the ability of an image receptor to respond to a low X-ray exposure. So, sabi ko na yan sa inyo kanina, there are factors that will affect screen speed. Kapag mataas ang speed ng screen natin, tataas ang density. Pero bababa ang detail. Okay? Kapag mataas yung speed, there's a tendency magkaroon tayo ng radiographic noise. Kapag nagkaroon tayo ng radiographic noise, there's a possibility that our spatial resolution, contrast resolution will decrease. This affects the detail on our radiograph. Next is latitude. Latitude refers to the range of exposures over which the IR responds with optical density in the diagnostically useful range. So kung mapapansin nyo, density, contrast, speed, and latitude, these all can be seen in our characteristic curve. Okay. So, an image receptor with wide latitude. Paano natin masasabing wide latitude? Once na na-plot mo siya sa characteristic curve natin. Kapag wide latitude, it means it has a long scale of contrast. Kapag long scale ang contrast, ibig sabihin mababa yung contrast. Okay? So, kapag naman ang ating image receptor is nagkaroon ng narrow latitude, it means we are dealing with a short scale of contrast. A short scale of contrast means high contrast. Okay. So, there are actually two na natira sa film factors, which is processing, the time and the temperature. So, katulad na nabanggit natin dati from the past topic, development time, it is recommended by a manufacturer. Nakalagay dun sa box ng solution kung ano yung development time dapat. Kasi once na mabago to or once na pahaba yung development time, there is a tendency na yung mga unexposed silver halide crystals ay magkaroon ng interaction. Magkakaroon tayo ng chemical fog. Kaya dapat susundin yung manufacturer, yung recommendation ni manufacturer. So when the development time extends far beyond the recommended period, the image receptor contrast will decrease, the relative speed increases, and the fog level increases. As well as the development temperature, we have to maintain our development temperature at 35 degrees Celsius. Once na magkaroon ng pagbabago sa temperature, magkakaroon ng pagbabago sa activity. An increased temperature for our development or for our developing solution, mas tataas ang activity, mas tataas ang chemical fog. Okay, fog level increases with increasing temperature. Now let's proceed with the geometric factors. First, we have distortion. When we say distortion, it is classified by two. We have shape distortion and spatial distortion. So, unequal magnification of different portions of the same object is shape distortion. Spatial distortion is a misinterpretation in the image of the actual spatial relationships among objects. So, the distortion will depend on the object thickness, position, and its shape. Okay, so this image, we can see a thick and thin objects. So thicker objects will result in unequal magnification and thus greater distortion compared with thin objects. Tatandaan, kapag makapal yung object, mas mataas ang distortion. As well as the shape and position. So, kung makikita dun sa second image natin, object thickness influences distortion. Radiographs of a disc or sphere appear as circles if the object is on the central ray, meaning there is no changes when our object is parallel with the central ray. Pag sinabi nating parallel sa central ray, nakadirect. Hindi siya naka-placed laterally. Alright? When lateral to the central axis, the disc appears as a circle and the sphere as an ellipse. So, kita nyo yung pagbabago if ang shape natin is thinner or same shape or flat, there will be no distortion. Kahit i-place mo siya sa lateral side ng central ray. Unlike kapag sphere, yung ipinlace mo na object, once na maglagay ka ng object sa lateral sides ng ating central ray, there will be a distortion. An example for that is the skull. As I've said, skull has too many projections and there are many central ray angulations. And yung distortion na yon is kailangan clinically para may ma-view tayo na certain parts of the skull. Okay? So, when we say central ray angulation, yun yung nababago yung pwesto ng X-ray tube. Meron tayong tinatawag na caudal angulation and cephalad angulation. So, pag sinabi natin cephalad angulation, yung mismong X-ray tube natin will be pointed towards the head of the patient. Kapag naman caudal angulation, masasabi natin siya na yung X-ray tube is facing towards the foot of the patient. So, kapag may pagbabago sa angulation na to, there will be a distortion. Okay? As well as this image, irregular anatomy or objects such as these can cause considerable distortion when radiographed of the central ray. Tatandaan kapag nakaparallel ang object with the central ray, meaning nakadirect yung object galing sa linya or galing sa source ng central ray, walang mangyayaring distortion unless magkakaroon tayo ng magnification. kung magkakaroon ng certain distance yung object from our image receptor. Pero kapag yung object, ipinlace natin siya sa lateral sides ng source ng central ray, there will be a distortion. Even the inclination of the object, it will produce distortion. Okay? So, meron din tayong mga projections kung saan yung part na ating under examination should be inclined. Okay? So, ito yung sinasabi ko, magnification. Even though that the part or the object under examination is in parallel position with the central ray, there will be chance na magkaroon ng magnification. All images on the radiograph are larger than the objects they represent. It is a condition called magnification. So, ang nakaka-apekto kay magnification is the SID and the SOD or SID and OID. Okay? So, quantitatively, magnification is expressed by the magnification factor. So, ano ba tong magnification factor na to? Okay. Magnification factor is equals to the image size over the object size. Si object size, makukuha yan. Alam natin yan. Kasi pwede siyang masukat. Si image size, it is somehow like estimated size siya. So, pag hindi sure sa object size, pwede rin naman gamitin itong formula na to. Magnification factor is equals to SID over SOD. SID means source to image receptor distance. SOD means source to object distance. Okay? So, that is the magnification factor. Now, baka nalilito kayo kung ano yung SID and SOD. Okay. Wait, paano ba ako magagawa ng note? How can I? Yan. Burahin muna natin to. So, SID and SOD. Let's say this is the patient. Alright. The patient, here is our X-ray source or X-ray tube. This is the image receptor or yung cassette natin. The SID is the distance from our source to the image receptor. This is SID. Again, it is the distance from the source going to the receptor. Now, what is SOD? SOD, palitan natin ng color. SOD is the distance between the object and the source. The distance between the patient and our X-ray tube. May isa pa tayong tinatawag na OID. OID is the distance of our object under examination to the image receptor. Okay, so yan yung pagkakaiba-iba. SID, distance of our image receptor to the source of our X-ray. SOD is the distance of our object under examination from the X-ray source. And OID is the distance of our patient of our object to the image receptor. Okay. So, magnification factor. Once that our OID increases, okay, so once that our OID increases, there's a possibility that there will be a magnification. I want you to make an experiment in your home. So, try nyo lang naman. Get some flashlight, may it be from your phone or an actual flashlight, and then itapat nyo siya sa wall. Okay? So, from that distance, ilagay nyo yung kamay nyo malapit sa wall. And check the shadow. Okay? So, yung shadow, yun yung magde-determine if what will be imaged on a radiograph. Okay? So, kung ang ating light source ay inilapit mo, what will happen to the shadow? And if the light source is brought away from the object, anong mangyayari sa shadow? Okay, so check nyo. And isa pa, from your first distance ng light, yung object naman mismo ang ilayo nyo sa wall. So, for example, yung kamay nyo nasa wall, ilayo nyo siya. Pero same lang yung distance ng pinanggagalingan ng light. Tingnan nyo anong nangyayari sa shadow. Lumalaki ba siya? Lumiliit? So, kapag na-try nyo na malayo yung kamay nyo sa wall, pero yung distance ng light nyo ay ilalayo nyo ulit, tingnan nyo kung ano mangyayari sa shadow. Okay? So, that is the magnification. Kung nakita nyo yung ganong, kung anong nangyayari sa shadow, you will understand what will happen if there is a difference or pag may pagbabago sa SID and OID. Pero tatandaan nyo that in most medical images, the smallest magnification possible should be obtained. Okay? So, iniiwasan talaga natin na magkaroon ng magnification. For example, a chest x-ray examination. So, di ba yung heart ng tao nasa gitna? There is a gap pa bago magkaroon ng bago pumunta sa mismo chest area. So, that gap is considered as an OID kapag pinlace mo yung patient nang nakaharap sa cassette. An increase in OID will have an increased magnification. Iniiwasan natin na magkaroon ng magnification sa heart dahil it could result into a different diagnosis. Okay, so in order to compensate the magnified image of the heart brought by the OID, we have to lengthen our SID. That's why yung mga standard na SID na ginagamit, especially for chest x-ray examinations or any examinations na magkakaroon ng increased OID, it is a 72-inch SID. Okay, so to minimize magnification, we have to use a large SID if there's an increased OID, and as much as possible, place the part under examination as closest as possible to your image receptor. Because once that the OID increases, there's a magnification. Alright. Next is blur. A blurred region on the radiograph over which the radiographers have little control results because the effective focal spot has size. So, ito yung tinatawag nating focal spot blur. So, this is the most important factor for determining spatial resolution. Okay? So, bakit ba tayo nagkakaroon ng focal spot blur? It occurs because the focal spot is not a point. Okay? So, actually, akala ng iba, or akala ng karamihan, yung pinanggagalingan ng X-ray natin is a point, where in fact, it is a rectangular source. Okay, rectangular source of X-rays that varies in size from approximately 0.1 to 1.5 mm on a side. That is the focal spot. Kung naaalala sa physics, we have a large focal spot and small focal spot. Okay, so using a large focal spot, it means mas malaki yung sakop or mas malaki yung source ng X-ray compared to small focal spot. Small focal spot is used to have a greater detailed image. Okay, so the focal spot blur is small on the anode side and large on the cathode side of the image. I repeat, using a small focal spot can have a greater recorded detail. And when we are using a small focal spot, again, place the object as close as possible to the image receptor. Have a low OID or a short OID. That is the focal spot blur. Focal spot blur is small when the object to image receptor distance is small. Okay. Now let's proceed to the subject factors. First, we have thickness. Okay, so thickness of the patient. It is where a thick body section will attenuate a greater number of X-rays than does a thin body section. So, kung nakikita niyo si image, yung walang kinain na manok na bulate or na ahas, madami nag-pass through na X-ray. Compared sa kumain ng manok, konti yung nag-pass through. Because mas na-attenuate niya, mas na-absorb niya, kasi makapal yung part under examination. That is sufficient thickness. So the degree of subject contrast is directly proportional to the relative number of X-rays leaving those sections of the body. Next is the density. So tissue mass density is different sections of the body may have equal thicknesses yet different mass density. This is an important factor that affects subject contrast. Meaning, kahit yung braso mo is, sa tingin mo, iisa lang yung thickness, may part dyan na mas mataas ang density. Pag sinabing density, yun yung kapal ng part. So, kung mapapansin sa image, nag-pass through siya sa fats, sa muscle, and sa bone. Compared sa muscle, yung bone, konti lang yung nag-pass through na X-ray. Okay? Tapos sa muscle and sa fat, mas madami. Kasi mas na-absorb ni bone. Mas na-attenuate ni bone. Okay? Next is the atomic number. Effective atomic number. When the effective atomic number of the adjacent tissues is very much different, subject contrast is very high. Yung effective atomic number, ito yung sinasabi ko sa inyo na the parts inside of our body contains or have a different effective atomic number. Alam natin that if the material is high in atomic number, it has a high absorption of the X-ray. Kapag mas na-absorb niya, mas less yung magpe-penetrate. So here are the effective atomic number of some parts of our body. For bone, we have 13.8, muscle and soft tissue 7.4, lungs 7.4, and the fat is 6.3. As I've said earlier, one of the subject factors include object shape. A structure that has a form that coincides with X-ray beam has a maximum subject contrast, as well as the KVP. So this is the most important influence on subject contrast. When it comes to subject factors, the patient thickness, the tissue mass density, the effective atomic number, the object shape, it cannot be changed by the radiographer unless we have two deal with the changes in KVP. KVP has the penetrability action of the X-rays. So, kung makapal yung thickness or kung makapal yung part under examination, we can increase the KVP to penetrate that object. Kung mas dense yung object, we can increase the KVP to penetrate the object. Okay? But remember that lower KVP can produce higher contrast. But higher KVP can decrease contrast. Last is the motion. So this is the movement of the patient or the X-ray tube during exposure results in blurring of the radiographic image. One of the most pinanggagalingan ng motion artifact or blurring is the patient motion. So there are procedures of reducing motion blur. One is to use the shortest time as possible. Kasi kapag motion, yung sinabi natin, we have an involuntary and voluntary motion. Involuntary motion has the movement of our internal organs. Kapag sinabi natin voluntary motion, ito yung nagagalaw yung kamay, nagagalaw yung paa. So to deal with the involuntary movements, use the shortest time as possible. To deal with the involuntary or with the voluntary movement, restrict the patient motion by providing instruction or using a restraining device. And also use large SID and use small OID to reduce blurring or to improve the detail. So that is the radiographic image quality. Thank you.